Good. All right, so today's lecture is on just using Visual Studio. These are a lot of tips and tricks I wish I knew when I started out, and we picked them up whether in classes or from other people, so trying to get them to you guys early. I'm Jeff Morgan. I'm a junior at DigiPen. I was a programmer in the Air Force for a few years before DigiPen. I've worked on all kinds of teams, some good, some bad, and I've been a tech director and stuff. I'm really interested in using tools to be better, so make my teammates better, make myself better. So knowing a tool like Visual Studio helps a lot. So things we'll be going over. Just setting up your file directory for the first time. Someone before the meeting asked me about where to put libraries and executables and stuff like that. Those are the kind of things we'll be going over. Visual Studio has a lot of settings and a lot of things that you can get wrong, so we'll go over some of them. We can't go over all of them, but I'll just highlight where to find some of the things. Things like using build scripts, trying to automate these processes. And then actually the Visual Studio debugger. So I'm pretty sure everyone's used Visual Studio, but just in case, Visual Studio is an IDE. It has a text editor, IntelliSense. It's supposed to make your life easier as a developer. And then it has a debugger, which is also supposed to make your life easier. If something goes wrong, you want to be able to find it quickly. We'll go over some of how to do that later. The biggest difference really from my freshman year to my sophomore year was multiple project solutions. As a freshman, I had one project, so one solution with everything in it. If I was doing physics or math, they were in the same thing. If I made a change in math, I had to recompile physics. That doesn't make sense. So what we do starting once we get a little smarter, I guess, is we start breaking things off into smaller parts. So if I make a change in physics, I don't have to recompile graphics. This is going to really help compile times and whatnot because you don't have to recompile your whole project every time you make a change. It does add a little complexity though, so we'll go over that today too. So I was talking about file directories and stuff. Here's just an example of one. There's all kinds of ways you can do it. Here's one I'm currently using. You guys remember the Mercurial lecture last week, right? Green checks is just something that's like on source control on the server and pushed. Everything else can pretty much be deleted except the HG. But if we look at some of these files, okay, you can see them. Dependencies are where I'm going to put things that like external libraries I need, like a sound library I'm using or a Google testing framework or something I use. So I put that there. Game is where my actual executable goes. Library or static libraries I build myself, or if there was DLLs I was building myself, I would put them there temporarily. Project is where all of my Visual Studio specific stuff goes, my solution, my projects. I like to keep everything separated and organized, so if I want to give someone something, like just my source code, it's really easy to find it. If I want to clean, it's really easy to clean things. Scripts are things I use like for build scripts and stuff like that. Temporary. Visual Studio generates a lot of files. We'll talk about them really briefly, but that's where all the temporary files go, like OBJs, object files, have you heard of them? Basically when Visual Studio compiles like a CPP file, it makes it OBJ, and that's where that stuff goes. And then I have my build, my application for building stuff and my build script right here. It's just an example. You can do it in your own way. Just try and think about how you want to organize the data and how you want to separate it. So now that we have kind of like a setup of what our directory is, first off, everyone knows what a solution is. So a solution kind of houses multiple projects or one project. It holds your whole everything. And then a project is smaller. So projects have settings that affect how they build, how they link with other things, where they output to. We're going to go over all of that. Some of the really important ones, I'm just going to highlight in red and then talk about them really briefly. So like an output directory is where your executable goes. And configuration type is like, are you building a library, which is something that builds into your executable, a DLL, which is something that you link against when you run, or an executable, something you can double click and it'll run and do something cool. One of the really important ones is working directory. That's under the debug tab, and it's basically how you can find files. It's if you're looking for a texture or something, it looks from the working directory. So if you can't find something when you just double click on your executable, but you can find it in Visual Studio, that means your working directory is messed up. And that's a common one. Next one, you can manually include things to look at, to link against, or to basically find definitions for files or functions. I don't recommend doing that. Later we'll look at build scripts that can do it. But if you wanted to manually do it, you could do it in VCC directories. Another important one are warning levels and treating warnings as errors. Treating warnings as errors I think is good because that means errors or warnings get fixed. And a higher warning level, I would go warning level 3 is what I do. 4, you get a lot of warnings. Some of them aren't useful to me. That's up to you guys, but this is where you find them. Optimization, if you count no optimization, there's like 4 types. You can optimize for speed, you can optimize for size. Sometimes size is faster. You can try for both, or you can not optimize at all. One of the most helpful things for me is pre-processing to a file, because if you write with macros, you can't really see what's going on. So you can tell Visual Studio to say, hey, output this to a file so I can see it. And I can show you guys examples of this later if you remind me. You can do the same thing, I don't have it on this slide, but with assembly, you can have it output all the assembly code. So you can see what is getting generated when you write code. Runtime library causes a lot of errors. So basically, Visual Studio has a runtime. It's either static or dynamic, and it's saying how the Visual Studio specific stuff links to your program. Most DigiPen games use static, so they use, I think it's MT, I can look. If you get a lot of errors with that, that means one of your libraries has a different type than everything else in your game. So everything has to be the same. And this is all stuff we'll show in a little bit. Runtime type information, a lot of people turn that off. It's under language. The really important one is precompiled headers. We're actually going to show precompiled headers and create them. But basically, you create one precompiled, you can use one file to create your precompiled, and everything else uses it. What this does is it speeds up compilation times even more. Because something like DirectX or Windows, these really big files that are going to change, you don't want to recompile them every time. So you precompile them and just use them everywhere. And I already mentioned the assembler output. A couple other ones, I force include precompiled headers. Some people say that's bad practice. To force include something means you're not going to see it included. So right now, if you want to include something, you say pound include something. With force include, that's not going to show up. It's just going to happen automatically behind the scenes. There's other options, like you can force using. They're all under the advanced tabs. I like show includes if I don't know where something's coming from. I'll turn that one on, and then in output you'll see a lot of all the includes where things are. It just helps in debugging if you can't figure out why something's being included twice or something. Show includes the way to go. Linker show progress. You can find a lot of really cool things there too. Basically, like if things get dropped or not being linked or not being used. Verbose doesn't do exactly what I thought it would do. I thought it would give me basically the show progress stuff. It doesn't, but it's useful. Okay, another one is property managers. I'd rather just show this one. I have a picture, but I don't think it's very helpful. So all of these, that's a lot of settings, right? And I really briefly went over them. Having to set these up manually for every project doesn't make sense. Someone's going to make a mistake, a project's not going to work right. So what a property manager does, it lets you set solution-wide, well, actually for a user, all of these settings, and then they can be overridden on a project. They also let you set up user macros and build events. You can find that by going to View and then Property Manager. And then there's also solution settings, which solution is bigger. It contains all the projects. Some of the things you can specify here is what project starts up. You can set up to start many projects at once instead of just one. I'll show an example of that in a little bit. Project dependencies. So when you have lots of different libraries, some libraries depend on other libraries, or your executable, your game might depend on physics or it might depend on graphics. So you can't build your game before you build physics or before you build graphics. So that's what project dependencies and build orders are. And configurations, debug and release are configurations. That didn't work like I thought. So basically, you can make your own too. I've seen someone make it where their physics and their graphics was optimized and then everything else was in debug. What releaser do is it asserts and things like that are optimized out. It's going to be faster, but there's not going to be not as much checking. Make it a habit to run without the debugger. Sometimes it can be different. When you're running in a debugger, there's still some magic that happens behind the scenes for you. And then some reason your game won't work because you did something wrong and Visual Studio is covering it up. So Control F5 is like a hotkey for that, a short key. Okay, so I kind of want to go over, before I go over build scripts, show some of those settings. Right off, did anyone have any questions? I know that was really fast, so if there was something specific someone wanted to know more about, I can answer that. Okay, so a property manager, if you go to View, you can go to your property manager. It'll come up with a user. You can add one. It's the same, for mine, I don't use this very often, so it's the same in debug and release. So if I make a change in release, it's going to apply to both. You can add specific ones, so I could have one for release, one for debug. And basically all of those things I was talking about before include directories, library directories. I can set those for everything in here. So you see that all of these multi-projects, they all have a property sheet. So it would set it all across the board. So I wouldn't have to set it specifically for everyone. At the same time, if I wanted to go in specifically do it, I could right click, bring up my properties, and I could go into any of these and set something specific to that project. Again, if you look at all of the possible settings, there's more than I can keep track of. And I've seen a lot of people try and manually set these up, and it's just error prone. So what we want to do then is start using things like build scripts. We want to automate this process. Some of the benefits of automating this process is that you're only going to have to change one thing. If you change how your libraries are set up, you don't have to change it all over. There are many different build scripts. I use Premake. There's CMake. I guess you could count Makefiles maybe. There's other ones. I'm going to show Premake just because that's the one I use. It looks like Lua. I don't know who's used Lua or not. And it gives you a lot of control over your build settings. So here's an actual example from the build script I use, where you can do things like specify the type of the project, the language. You can specify where everything goes and how dependencies work. So it's pretty simple to use and it's pretty powerful. So let's go to that. So basically, we saw my directory before. I have the Premake here. So it's the same Premake. It's in that file. What I can do is I can specify things like the libraries I have. So instead of going into Visual Studio and directly creating new projects, new libraries, I just do it in a text file. So same thing for flags and dependencies. All of this is automated now. I don't have to manually do it for everything. What this lets me do is I can say, Premake clean, and it'll go through and clean things. But I can also say Premake Visual Studio, and it'll go and it'll generate basically projects for me. So now if we go in here, I have a solution. I have different library projects. I have my test projects. All of that was generated by the Premake script. So I couldn't make any mistakes because Premake did it for me. That makes sense. One downside is if you have a project up, you have to say yes a lot. And Jason last week showed a way to get rid of that. We're going to more specifics on it in a sec, but well, actually, are there any questions on this Premake? So when you actually have your have a project up and running, the biggest part about Visual Studio for me isn't really the text editor and the IDE. It does give you a lot of benefits with like a telesense and stuff, but it's really the debugger. Because there's other text editors out there. I haven't used a better debugger though. So here's some of the things we're going to talk about. I'm actually just going to go into Visual Studio and just show them instead, all except the AutoEXP. What this file does is it lets you visualize your own data structures in the debugger, like in a watch window. I don't know what that was. Okay. So the first thing is breakpoints. Everyone's used Visual Studio, maybe? Okay. So if you put a breakpoint, it'll just stop it. One thing I didn't know was conditional breakpoints. So if I right-click on this breakpoint, I can put a condition. And if this condition is true, it'll stop. You can do is change to. So I can do one like if this is greater than 0, break. And if it's less than 0, don't. So I say if so if that's true, it'll break. If not, it won't. So this time it shouldn't be true. Oh, I didn't set my startup project. Sorry. Standard test. Yes. Okay. So I set a condition on this breakpoint. instead of having to hit it every single time, which is really, really slow, I only want to hit it under certain conditions. So that condition, I just knew that this function would not return negative. But now if I say greater than 0, I stopped and I actually hit this. So that's a conditional breakpoint. Another one is a data breakpoint. If you go to the breakpoint window, which is under debug window breakpoints, you can add data breakpoints, which will break on memory. So you see that has a memory location. So I can say new data breakpoint. I can put an address down, and it'll break at that memory when that memory changes, which is really, really useful sometimes. Another one that I like is called a trace. And what that does is it'll print out whenever it hits that breakpoint. So I click the when hit, and now I'm just going to print a message. So I'm just going to use their standard message. I'm going to put a breakpoint just before so we can see it. So you see as oops, I passed it. I'm going to redo that one. You'll see as I step over it that it prints it out here that I hit it. So it's kind of like instead of me putting in a print statement all over the place, I can use Visual Studio to do those kind of things for me. Beyond that, there's a few windows that automatically display data. I like autos just because it shows you return types on functions. So basically, you'll see here that this function returned a certain value. Before, I used to look at registers and try and like cast the register value until someone was like, dude, autos does that for you. Local will just display local things to the function. I'm not sure how they actually pick what to show. I just use autos for return type. If I actually want to see something myself, I will go into the watch window because watch is kind of cool. You can type things yourself and it'll evaluate them. So I can say expected result and it'll show me that. I could cast expected result to another type and it would take care of it. It's really simplistic. You can't do everything you can do in C++, but you can do a few things. Inside of the watch window also, you have a few symbols you can use, like all of the registers. Registers are just where data is stored on a CPU. I can say like @EAX or $EAX. What if I could say EAX? Yeah, or EAX. In order to display that for me. You can format it in different ways. It was already on sign. So it's just really easy to see a lot of data in watch. That's why I use that one. Another one is @error. If you say @error, that'll bring up Windows ones. So I picked a H result, and it just told me the status of that. There are others. I put a link up there for that. The next window I'd want to talk about is probably disassembly. What disassembly is it shows you the assembly that's generated by your code. So you see that that's tied to my lerp in place. Like this is C++ code. I can pick what to show. So I want it to show the source code on line numbers. It makes it easier for me to read. I don't go into this a lot, by the way. It's just if I have a problem or if I just want to see something I'm curious, this is where to do it. And I can step through this now, and I can step through the assembly generated. So that's disassembly. And most of these are in the windows for debug. Another one is registers. This you can show registers in different registers in different formats. I don't know how useful that'd be for you guys. It's just if you're interested, that's where it's at. Let me see. The call stack, that's an important one. Basically, it's all of the functions that have been called up to that breakpoint. So you can trace back. You can click on it. I'm in disassembly. It's showing me all of them in disassembly right now. But if I had another, let's see, function. There, you see I went from lerp in place on the call stack just by double clicking. I went back. I can see the values that are called with, if I copy and paste it. All right, so that's most of what I use off the top. Step into and step over. By the way, you can control it with F10 and F11. So F11 are just kind of skip things, and I had it backwards. F11 are step into things, F10 are skip. You might not always want to go into something, so it's just a way to control it. You can also do a few other things like running to a cursor or skipping it. If you're using your watch window, you can change values of things. Let's see. So like I could take the result and I could change its value, and then it will return. If I looked at autos, you saw that it returned the value that I changed to. Okay, so I'm gonna get out of these windows. Okay, back to it. Are there any questions about that stuff? Okay. Another thing people have been asking me a lot is Visual Studio does generate a lot of files we were talking about. Oh. Mm-hmm. Mm-hmm. You know, I'm not sure. I could try it out, but I'm not sure, honestly. When you say a watch expression, you mean like?
The traces. Like, could you have a print a variable? Right.
Oh, you know, I'm not sure. I don't know how it would grab them. You can include the value of a variable or other expression in the curly braces. Yes. Yeah, so it printed out the result of that variable. So what he asked me is if you can print out variables from a trace. What you do, it tells you how to use it in the actual trace window. So like I just looked just in and found out. You just put it in a brace and then put the variable. You could also run macros. I'm not sure what that does. One of our teachers, Cody Pritchard, was telling us about it. I haven't had to use that though. Okay. So anyway, Visual Studio does generate a lot of files. So a lot of people wonder what to submit, what they can delete safely. Anything that's your own stuff, like a user, if it says user, something user, delete it. SDF is the biggest file that gets generated. Precompile headers can be big. But you can delete that. It just gets regenerated when you rerun the solution. Filters, okay, I wouldn't delete those if other people are using them and they're shared on your source control, because that means everyone's filters are messed up. But they're not going to break anything if you break them. It's just going to unorganize people's data. PDBs, well, a PDB is just symbols for your solution, your project, your code. So when you're running in debug, you have symbols. You can see that this variable name is something like variable foo. C++ doesn't look at it like that though, or the compiler doesn't really care. So that's for us. So if you don't have any errors, there's no really reason to say the PDB. If something broke and you want to debug it, you might need that PDB. You need that PDB to be exactly matched up with executable. So if you're worried about things like mini dumps or crash dumps, then you need the PDB. If you're not worried about that kind of stuff, then you don't need the PDB. Simple. The solution, if it ends in .sln, that's your solution. Don't delete that. Anything in project, don't delete. Your source control stuff, don't delete. That's an important one. I've been the guy that broke SVN a few times. So then a few other things is, to use Visual Studio better, I would look at Visual Assist. What Visual Assist gives you, you can right click on something, say refactor, and I can rename this everywhere it shows up in the engine. So that's really, really handy. Macros, like, I define my own macro, so that Doxy, Rhino. I don't know why it didn't work actually. Normally I have a macro that puts my headers up for me because I'm too lazy to write them. Visual Sys helps with a lot of that kind of stuff. Anything that ease of use, I can press a button and go to. Normally I can press a button and jump to like an implementation of something or a definition or declaration. Okay, so now I kind of want to talk. Sorry. Oh yeah, and make sure just to learn how to use your editor pretty well. So there's better editors, so whatever you use, just make sure you know how to use it. Like if I wanted to replace text or whatever, I could do it pretty simply just because I know how to use my editor. Learn how to use it well. There's shortcuts for how to use things. I would either search through the documentation for it or just play around in it. Some of the ones I use a lot are, if I can get back, Control-Shift-F to find everything. You can pick where you find it at. There's a few other ones, but just get used to using it yourself. Whatever you're comfortable with, learn how to use it. Whether it's Sublime for your editor or Visual Studio. There's other options too. Another one is, someone told me they didn't know how to change tabs and stuff. So most of your fonts and settings are in Tools option. This brings up, there are environment and project stuff. What I'm interested in right now is text editor. If you go to C++, you can check your tabs and set all that. Formatting. You can format other languages too. I don't really generally mess with those. I do mess with fonts and colors a few times. I don't remember where that's at off the top of my head. I just change my colors a lot. Some things don't work well. Some color schemes. So before questions, I just kind of want to show, since there's a lot of things, so like if for my projects, I need a precompiled header, I need a main for my test projects, I need a dependencies text file. That's a lot of stuff to have to manually do. So you can do things like, one second. Underscores are the devil. So like I made a bat for my project at home that like I can make a project called Awesome or something like that. Bat command. Oh, maybe I have to be on the Windows one. But I made a bat that works in command, CMD, that are just like make a new project for me, and then I just go and add it into the Premake. And it's simplified having multiple steps where people can mess up into just being like a two-step process now, where they just make the new process and then add it to Premake. So instead of having to manually add things and then getting errors when like a precompiled header wasn't there or main wasn't there, I just made a little simple script to do it. And that's the point of things like build scripts. It's not that it's really, really hard, it's just that it's error prone. So now I kind of want to look at some of the things to actually set in a build script. These are some of the options we talked about before. You can do everything from like set filters, which is what this does. It's an ugly way to do it, but this is just setting filters. Setting dependencies, what you include, what you don't include, where everything's located. So I can change where things are located or where they're output with, and it's pretty simple. Then I just run my script one more time to say like, I would just clean it and rebuild it, and then all my stuff got regenerated if I were to change something. And I can add things in other libraries, or all my projects, or get it, instead of manually having to go in and right click on it. Oh, that reminds me. Sorry. Okay. Which reminded me about something else I mentioned earlier. you see here, this is a really small, this is a project I just started off for junior year. So I have a few libraries. Normally you wouldn't have a meta and a meta test. That's just how my team does it. Your team might do something totally different. But you see, I broke down containers and math and meta and utilities, and those are all separate. So say I wanted to do something like start them all at the same time. I could right click on set startup projects and then go and pick which ones I want it to start. Sorry, right click. So we do this sometimes on my team just when we're trying to make sure that we didn't break anything in any project. We're going and run all of the tests. So now if I were to say F5, I would get a whole bunch of pop-up windows. My keyboard shortcuts aren't working. What are other things? Configurations or something I talked about while that's building. Oh, now it built. And what configurations are? We said debug and release. If I want it, I'm not saying this is a good idea. I've just seen other teams do it. I could set, I can make a new configuration. I'm going to choose to copy it from debug because I want most of the stuff in debug. And then I could go and change, say, math to be into a different configuration. So now it's almost like being in debug. It's my awesome configuration, except some things are in a different, more optimized setting. I generally don't think that's a good idea, but I've seen people do it. That's most of what I do at the solution level. Okay, so I've kind of been all over the place. Are there any questions? Yeah? Okay.
So say you have a math library. Say you have a math library, and you can make a static library, keep it separate, so you're not constantly reading all of that because you're not going to change that much. So that would be one library. Then the library say you had a serializer, and then from that base serializer, that probably won't change. Other people can make their own serializers that inherit from it.
Mm-hmm.
I was thinking about making that a library and part of my core engine class, and just put that in a static library, and then if someone makes a new serializer, they just inherit from it, and they'll begin whatever project they put that in.
So you're saying what granularity to divide projects up into?
Mm-hmm.
You're saying what granularity, how small to make projects, or how independent, or?
What things would you run into problems with separating out projects, like maybe some general do's and don'ts with separating certain things and keeping things together?
Okay. By the way, if anyone has good advice on this, help me out on this one. But generally what I do is I try and keep really related things together, and I try and think what builds on what. So in utilities, I have things like errors. So this is all I have in my utilities so far. I have an error logger. I have standard functions, standard type defs, things that are going to be used everywhere. So this is one of my core libraries that other libraries use. So then my math library actually links against that one. So utilities has to build before math. Anything that used math would have to be built before that library. So graphics would use math, it'd have to be built after. I try and relate things by what they do. So utilities is one that's kind of difficult just because it's general. But containers are things that store data. So to me, it's really easy to group those because they all do similar things. They all have similar functions. I've seen people get into trouble where they have to link every single library against every other library.
The execution
Yeah, but that's true. I've seen people have to have their libraries dependent on other libraries though. And you want to try and avoid that as much as you can, just because that means that's more things that have to recompile. Repeat that, sorry. Okay. So you can manually set it if you go in the solution and right click. If I wanted to set the orders things were built in or they're dependent on, they're really the same. So I'm on my meta test project. Right now it's really only dependent on meta just because of how my project works. But I could click and then what would happen is if I were to rebuild, it would rebuild the things that it depends on. So I'm telling Visual Studio right now that my meta test is dependent on all these other libraries. Same for build order. Build order gets generated based on that, but it's telling this is the order things are going to be built. So utilities first, meta test last. So, and I could change all that, which I don't know why I would. Are there other questions? It was short. Cool. Well, thank you for, yes?
Precompiled headers.
Yeah, I was supposed to say that about that. Thank you. Okay. That's a good question. Precompiled headers, how to use them and stuff. You see I have a containers and I have a precompiled.h pp and cpp. If I right click on the properties, let's see, Solution Explorer, precompile. It's under General, C++, precompiled headers. One's going to be create. And then at the solution, if I look at the solution, it says, does that show up? At the solution, it says using. Only one creator. So what happens is I'll go to precompiled and I'll set the mode for that. On the CPP file that I want to create the precompiled header is the one I would say create. So if I set this to use, then no one would be making my precompiled, nothing would happen. I only want one person to create it, so I right-clicked on the file that I want it to and went to its properties. And that was one that was create. And then it's at the project levels where I set that the whole project is using the precompile. And then also under that same tab, under advanced is where you could do something like force include a file. I do that automatically with my build script so it doesn't show up here, but I could type a file name and have it automatically do that. A few other things since we're here, code generation. This is an important one. So if you go to C++ code generation, runtime library, there's a few different ones that you can specify. Really they're the debug and release version of the same. One's static and one's DLL. If you're using static libraries and stuff, generally you're going to be using MTD or MT. If you get into errors, let's see. So like I switched the type here and I'm going to rebuild. And I have a lot of errors now. The one that tips me off most, you see, I can't make that bigger. Like a default lib, MSVC, those kind of libraries, MSVC, those aren't your libraries. If those are wrong, that's generally a hint that your runtime library generation is wrong. That setting is wrong. Are there other questions on Visual Studio, like settings and stuff?
For the folders that you were talking about, we're talking about putting all of the object files in a specific path.
Mm-hmm. Okay, so where to put like temporary Visual Studio files and stuff. Sorry. So I put those in temp. I think I built debug. So you see I have log files, object files, stuff like that. Last build state. It puts a PCH here, and then there's another one out. But I just put all those temporary files that get created by Visual Studio in a temp folder. You could have different names for it, but I just kind of separate that out just to clutter it, just because I don't like it cluttering up stuff. It's easy to delete now and regenerate and all that.
Is that done by your Premake or?
Yes. So in the Premake, I'm specifying like an out directory. So here, so I just call it my temp directory. I pass it in. Obs directory is what it's called in Premake. Different languages or have it, different build scripts or have it called different things. Just in Premake, it's called obs directory. So I just specify where that goes. Just like I specify libraries, what's included, things of that nature. Does that answer that one?
When you put up your presentation on Moodle, could you also put this as
The Premake?
build script?
Yeah.
Or is there a better place to go for?
I can link also to the Premake documentation. It's really good. I'll put this up as an example. Their documentation is really good though. Yep. Other questions? Oh, sorry.
The custom build step, I want to run a patch file. I'm talking to people and they told me you can do it, but if you like a run through how to run patch files for custom build stuff like pre-build and post-build.
I haven't done it in Visual Studio, so I use, I've done it with Premake. Huh? No, Premaker, it has settings for those kind of things. So I can say, that's a lot. Basically, I can have like a post build command to do something. So Premake makes that really, really simple. I just say post build command and then I say something, and it'll take care of that. I'm not using it currently. I've never done it through Visual Studio though. Are there other ones?
For that pre-compiled setting for create and use,
Mm-hmm.
do you also do that in Premake?
So for generating pre-compileds, I also use Premake for that too. So I showed how to do it manually in Visual Studio. Premake makes it really, really simple. What I do is I say PCH header, PCH source. One thing that kind of got me is precompiled headers. Visual Studio wants them to just be the name of the file and not the path name. But the CPP file that actually creates and uses it has to be the fully qualified like path. That was just a weird issue. So I just comment that for whoever used it. But so yeah, it's really, really simple with Premake. And again, there's other build scripts out there too. You don't have to use like Premake. That's just what I use. But it takes a lot of the things that are complicated in Visual Studio, I feel like, and makes them really, really simple, at least for the very, very basic use cases. One issue I did run into was filters. In Visual Studio, I can just like right-click on a project and say add a filter. Oh, I didn't see that. So I added a filter, and then I can just put code in there or whatever. And it doesn't really change anything. It just changed some XML file somewhere. I can't do that from Premake as easily. So what I had to do is, if you look at actually my code, like my source folder, we have that. No, I don't use very many filters right now. But what it does is it automatically generates them based on my file directory, which is kind of weird. So that means if I add new folders, like so, I have a filter source, filter container. And I couldn't find a way to really fix that off the top. It's just something different. Yeah. Are there other questions on like Premake or Visual Studio, any of that? Cool. Well, I hope this was useful. Thanks again for your guys' time and everything. I'll post all this on Moodle and the Premake. Thank you.